language community at Directorate General for Translation of the European Commission. And together with my colleague Borislav, who is also an LTC at for the Bulgarian language, we will show you one project in the field of AI that we have co-developed together, which is called TermiteOne. So just for a bit of context, we'll first mention the AI at EC Network, which is an initiative that originated in our Directorate General for Translation and has since grown to hold over 3,700 members from not only DGT, but also all the other Directorate Generals of the Commission, other European institutions and agencies, and the list continues to grow. So now it's a Commission-wide initiative, but with support from other institutions as well. And this network has 3 main action strands. First one is to find out what AI can be used for in our professional setting. Then the second one is helping us explore how that can be done. And the third one is just general sharing of knowledge about AI. And these are some of the examples of what we have been busy with in the AI network. These are more of the conventional NLP tasks, and term extraction is one of them that we will talk about today. But also, I would like to mention that the AI network experiments with GPT technologies as well. So when we move on to our project, TermiteOne, we were basically envisaging terminology extraction from English originals that could be used for various purposes by various actors. So we have a central terminology unit, and also each language has their own terminologists. And these can use automatically extracted term lists to do proactive terminology work on central projects, and they can use it in conjunction with other extraction tools which already exist. Translators themselves can use this early on just to gauge the difficulty of a text that they're up against, to see if they're going to have to contact an expert or not, just by looking at a term list, and factor that into their process of translation. But also, they can take this monolingual term list and create a target blank bilingual term base that they can plug into their translation software and fill it in as they go. And then once they have this terminology, they can, for example, use it at the end of their translation to perform a terminology consistency check. But we were also thinking about some automatic uses for this data, such as improving terminology consistency in e-translation or enriching documents in our databases with metadata, or using it for detection of terminological similarity among different documents. So the way we decided to try and approach this was, well, these are the kind of technical terms for training the model. But basically what we did is we decided to take what is conventionally used for named entity recognition and use it not for recognizing named entities, but rather terminology. And as a basis, we used the EU legislation. And so what we did is we took a lot of, I think that's going to be on the next slide. You can see down here all the tools that were used in the process that we had available via the AITC network, for which we are very grateful. We took what we knew was good terminology, good quality terminology from various sources, pruned it a bit, and then extracted from Eurolex sentences that contain that terminology. And then we tagged that terminology in those sentences, and then we played around with bands of how much terminology there should be in a sentence in order for the model to be good. We trained 2 models. The first one was trained on a larger data set, and the second one was used on a much smaller and more targeted data set. In the end, we found out that the 2 models produce slightly different results. They catch slightly different terms. So we decided in the final product that we have now to use both models in conjunction, and you will see a bit of that later. Here you can see on the right, it's called the BIOS tagging method. So we also enriched everything with part of speech tagging, and also, and then these marks. So O means this is not a term, B means beginning, I means intermediate, E means end, and S means single word term. And yes, so then TermiteOne was born, and we had our colleagues at the technical unit build us an interface for it, where our colleagues can either indicate the number of a document they would like an extraction from, or upload their own document, and then they input their email address, they press extract, and then they will get an email with an Excel file. The email looks like this. They can also submit feedback, which we use for ideas to keep on improving the tool. And when they open the Excel, it can have up to 4 sheets. So the first one is the terminology extraction per se. And here the individual columns with metadata frequency is obviously how many times that term is present in the document. Detection means how many times it was considered to be a valid term. IATE is our terminological database, interinstitutional, that I'm sure most of you will be familiar with. So it also checks whether that term is already present in IATE, and if so, whether it's a primary term, because that would indicate that it has a very high chance of being covered by all the target EU languages. And then example is a sentence, the whole sentence where the term was extracted from. Then we also have some conventional programming elements incorporated into the tool, such as extraction of defined terms, which means that just take any sentence that has quotes at the beginning, it will take what's in the quotes, consider that a term, and take the rest of the sentence as the definition. Then the tool also tries to extract acronyms and tries to guess their meaning. And then we have a third model that runs named entities, and this one was taken off the shelf. So that is not our in-house trained model, but it's still, colleagues find it useful. Then we tried the tool on various texts. So these are large legislative acts. And I mean, these are just term lists, obviously, extracted out of those legislative acts from different technical areas. And this is what the model was trained on. So we were expecting it to perform well here, and we weren't disappointed. But then we also tried using it to extract terminology from things that it wasn't really trained on. So first we went to our own in-house press releases. And here you can clearly see that the topic of the press release is at the top. So you can see that, as I was mentioning in the beginning, one of the use cases is to have a quick overview of what a translator is up against. And these kind of lists are quite useful for that, even with longer texts. But then also what we wanted to do is to try and take it out into the big world and see how well it will perform in texts that it hasn't been trained on, such as a weather forecast. And it performs quite well also with recipes. User manuals, they are quite technical texts, so these will be these will be closer to what it was trained on. On the other hand, it doesn't do too well with speeches, but it did great with a horoscope. And here, if you just take a look at the list, you can see the kind of language that's being used in those kind of texts. So that's also quite interesting to look at. I'm just going to hover here for a little bit. And then if we move on to popular literature, we also tried the Little Red Riding Hood. And here's a comparison, because this is an extraction done only using the first trained model, whereas then it's compared with an extraction done using both models. So you can see that it captures much more, but still not noise. It's useful terminology. And to conclude this part, also a comparison of the first model versus both on my favorite poem. If you don't know it, highly recommend. And the second one, which combines both models, will actually get you an extraction that contains pretty much all the terminology there is in the poem. So we were really thrilled about that. And with this, I will give the floor to Borislav to show you an interesting live demo part of this presentation. Thank you very much.
Thank you very much, Matej. Thank you very much to everybody to be here. Hello, everybody. So it will not be exactly a practical demo because we don't have access to the interface just now outside of the business hours, but it will be something I hope you'll see more interesting. Let me just share my screen. Okay, that's it. And okay, we can start with this question, actually, which I hope and I guess it's quite interesting for everybody here. What about large language models? What about these models which are so popular nowadays and which are able to do so marvelous tasks, so complex tasks? Why we cannot use them for term extraction? And actually, we can. Why not? Let's just compare a little bit what we have done. We use this LCTM CRF, which is much more simple model, much more simple architecture compared to the generative pre-trained transformer, GPT, which is the kind of models like ChatGPT, Gemini, all these famous models nowadays. And so our model is quite simple. It's, if I dare say so, it's half less complex than the transformers because it's just an encoder, and the transformer architecture is based on encoder and decoder. And of course, they used massive unlabeled data sets, so not prepared for the training. In our case, we used data which we prepared, we labeled the words we consider to be terms. So it was like a very specialized data which suited our goals. And so let's see what we can see as advantages and disadvantages using GPT for a large language model for term extraction. Of course, the clear advantage is that you can use a prompt written in natural language, which is much easier than to code in Python, for example, or any other programming language. It's very flexible, of course. We can precise the number of terms we want to extract, the domain, etc. Give any instructions we want to give to the GPT. These two, they used to be like big disadvantages, but now they're very much mitigated because the price per token we have to pay for each extraction, of course, if you're using GPT. But the price is going down rapidly, so maybe in the near future it will not be a big problem. Still, our model is not expensive at all. For the training, it was not expensive at all. For the use, not at all. Again, because using a simple machine with one GPU and it's sharing it with some other prototypes. So the price still much lower for our tool. And this one, large documents cannot be processed in one go. This also maybe is not true anymore because the windows is for tokens used by GPT are much larger now, but still it depends on the subscription and on the price. But this one is a real disadvantage, it's still valid. For example, the results are difficult to reproduce. It means that if we make an extraction using GPT, term extraction, and then we do again a term extraction, normally the terms, they are very different. Of course, we have some common terms like 30% or 40%, depends. But there are many differences. There are many new terms extracted during the second extraction and also during the third or fourth extraction. So it seems like GPT is deciding every time that there's some different terms which could be of interest for us. And then we have also, of course, hallucinations. This is something proper to transformers, by the way. We have made some tests with much less complex transformers. It was the same. Sometimes it gives us terms which are not in the text, like removing, okay, the less Serious is when it removes some words like of, the, when it changed the orthograph of a word, etc. But there's also some more serious cases when we have some term which is really not in the text, combining words which are not together. And of course, all this could be mitigated through instructions, but still GPT sometimes ignore instructions, even if we try very hard, and okay, just doesn't it just doesn't work. And then here's we have an example using TermiteOne and GPT on the AI Act, EU legislation. In green, we can see some terms which are quite interesting, and they are extracted by TermiteOne and GPT. I mean, the two of them, they detected these terms as terms of interest. But of course, there are also differences. Some terms will decide to be terms by GPT, and some terms were extracted by TermiteOne. And here in red, we can see some terms which were changed. For example, here you see data governance and management practice, and here we have data management practices. We actually, GPT removed governance and, which could be a good thing in general, but not for our text. For our text, we need really to have the terms as they are present there, and not to invent some terms which exist globally, of course, but they are not in our texts. Same here, localization is written in the American way using a Z, and of course, in the European Union, you use the S. It's not a big deal, of course. I don't say it's very serious, but still, it could be a problem, especially when you have like 3 or 4 or 600 terms. We should go over them. It's a problem because we have to check the terms to look for them in the text, and this we just lose some time because of this. And so now I would like to show you something more interesting, I hope, even more interesting than this. This is just a small part of the same AI Act. Just you see Article 6 and Article 7, just 3 pages. And this is the result got using TermiteOne. We have these sheet terms, about which Matei explained already. We have term. This is the terms which were detected by our two AI models. Here we have the frequency, which was calculated using normal programming, using Python. This is the frequency in the text. Detection, this means the number of times when the models decided that this is a term. This is interesting for us, very interesting, because this is the data from IATE. Actually, we call IATE to check on each and every term to see if the term is in IATE and to get some additional information. And we can see that we have a lot of terms in IATE, which proves that the terms detected by our two are really terms of interest for us, because of course we put in IATE only the terms of interest for the European Union, the European institutions. And here, of course, we have an example, which means the context of the term, which can help a terminologist or a translator to make a decision whether this is a term and how to use it, how to look for an equivalent, for example. And now I would like to show you what we have made as extraction here. You can see this is the same terms extracted using TermiteOne. And then we have done 3 extractions using GPT, using this prompt. By the way, the prompt can be very simple, which is it can be just extract 18 terms. That's it. GPT will provide the result. It could be a little bit more sophisticated than this one, like saying, okay, we need 18 key terms. Okay, this one, there's a recent study saying that this one is not very pertinent, giving a person to the large language model, but it could help in our case because still it will limit in some way the field of interest, which means what is related to the European Commission in our case. And of course, here we ask for relevant and important for translators of EU legislative texts and specialized vocabulary. Anyway, of course, we can make a more longer instruction. We have made some tests before, and the results are quite similar, by the way. which is interesting. Of course, I will leave the more competent prompt engineers than me to talk about this one day. And then here we have the first GPT extraction. We have a second one using context, which means that we provided GPT with this one, with the results from the first extraction, saying, okay, extract again, 18 terms. And then we have a third extraction, which were not related to the first two. We just said, okay, now just do an extraction without telling to GPT that it has done already two extractions before. And let's see the results. Here in green, of course, are the terms detected by TermiteOne and GPT in one or two extractions, or even three here. You see, high risk AI system apparently is a really good term because it was detected by everybody. And if you look at the figures a little bit, the terms detected in common between Termite and GPT are 40%, which means that obviously the both they have some, how to say, they have some agreement about which are terms of interest, which are not, at least 40% of agreement. Then we have okay, this 40% is especially with the first and the second extraction, because with the third extraction we have only 70%. It's going down. And then if we look how close are the extractions of GPT between them, we have with no context is only 33%, first and third. It's less than between the Termite and the first extraction of GPT, which actually proves again that the results of GPT are not reproducible. When we make extraction of terms, we can get results which are very different between the different extractions. And this is for us, we consider this an advantage of TermiteOne. It gets exactly the same results every time. When we submit the same text to TermiteOne, we will get exactly the same terms, actually every time we do it. And here again, when we look between the extraction when you use context, I mean, when we have done second extractions, but with the knowledge which terms were extracted the first time, we have 83% of common terms, which proves that if we provide context to GPT, if we explain what you want exactly and what was done before, we can get some quite good results finally. But okay, it's extra work, of course. And then let's go back to here, and let's look to our conclusions. That there is a certain overlap between TermiteOne and GPT, and this is for the best, of course, because it means that our model actually performs very well, and at least at some level with GPT. And then we see, of course, that both are able to detect very interesting terms. But okay, this one I have already explained, that GPT sometimes alters the orthography of terms and invents non-existent ones, the hallucinations. Then, okay, this one knows to us about the GPT cannot always follow the instructions, which means that it was extracting sometimes regulation or even article or annex, which is really not of interest for us. And when we gave instructions to stop doing it, it continued. So, okay. And of course, it was unable to organize terms based on their frequency, which means that even if we use GPT, we will have to create one more layer of normal programming with Python or any other programming language in order to get this information, to be sure about it. And okay, this one is very subjective, of course, but we have, of course, consult different terminologies and translators at DGT, the European Commission. And in our opinion, the terms extracted by TermiteOne are more interesting for us than the terms extracted by a large language model, GPT in this case, which is seems to be logical because you used specialized data with a simple model, but the best model for named entity recognition. And then the GPT is a great model. It can perform really great tasks, very complex tasks, can edit text, videos, sound. It's really great, but still In our case, term extraction, we consider that a small specialized model, very specialized, can produce more interesting results for us at least. And with this, I'll stop here. Thank you very much for your attention, and maybe we can go to the questions.
Yes, Borislava, I will read out some of them. Matej already answered in the chat. There was a question whether TermiteOne is only available in the commission or also for outside. Unfortunately, for the moment, it's only available within the commission. But the last question is, how does it's from Marco Celeste. Marco, if you want to ask your question in person and turn on your camera, that's fine too, of course. Otherwise, I will read it out. Okay, I will read it out. It's how does the data extraction, data mining change with GPT or other AI tools?
Thank you for this question. I'm not sure I understand completely the question. What you mean, how it changed the data mining with GPT? I mean, maybe you want to bring some clarification?
I think maybe I'm guessing, but does this question mean how the methods of data mining change now that we have GPT available? I'm not
Okay.
sure if I interpret that correctly.
Okay.
Yeah, since data extraction existed before, how did it change with GPT and with other AI tools?
Okay, I will not be able to answer this one. Maybe Matej can, I don't know. But here we're talking about term extraction, and the data extraction is a little bit more complex task. I mean, term extraction could be, of course, some particular case of data extraction, but still it's quite particular. And okay, we are language technology coordinators. We are IT savvy, able to program and everything, but still our main business is translation. So fortunately, maybe you should ask this question to some AI experts.
Yeah,
It
no
is
problem.
term
Thank you very much
extraction.
for
Yeah,
the
Mark just wrote. He
But
is asking about term extraction, not data extraction.
yeah, and I think it can be extrapolated. And I mean, a text which has terminology in it is a relatively simple affair. If you compare it with a, I don't know, SQL database of I don't know how many dimensions, and you're supposed to synthesize something out of that, then maybe GPT can help you be faster. But for extracting terms, it's exactly like Borislav showed. For me, at least personally, I can say that I would prefer the conventional method because it can't make stuff up. So it will only give you what is there, and therefore I find that to be, and it's also reproducible. So I find that to be more reliable than GPT in the state in which it exists today. But it's an area that's moving extremely fast. So I might change my view tomorrow or in a week, and then I might not. I don't know if
Next one. Borislav, you want to add something?
Absolutely not. I confirm what Matej has
Okay.
just said.
Is TermiteOne term extraction based on frequency only, like synchrotherm, for example? If not, which criteria have you been using?
Okay, so no, actually, it's based on AI. This is a very good question because there are a lot of very good commercial tools based on frequency and some other criteria. They're the conventional ones. And when we started, there was no tool existed which were using AI, artificial intelligence, to extract terms. So we are like pioneers. I found one or two articles about this. Some, of course, there are some scientists they tried, this before us, but still it was the very beginning of using AI for term extraction. And even now, I think it's more developed. I saw some more articles appeared about term extraction using AI, but it is still a very fast developing field. So I hope you'll see some very good things in the future.
Maybe I would just add that the advantage here is that we used our own data to train the models, and so that it fits our needs and our purposes. So basically, we showed the model what we consider to be good and useful terminology, and it learned from there. And then I think in the background it uses probabilities just like any other AI for NLP, right?
Yes. I mean, of course, in the end, it's probabilities. Yes, but it's very complex anyway. It's very that's why it could do so marvelous things. But it's probabilities in the end, of course.
But it does link to the another question that I see in the chat, whether TermiteOne is already set up or whether it can be set for other languages. So the way we trained it is we only trained it for English, because most of our originals that we translate where we need the term extraction is English texts. They are drafted in English and then they are translated to the other languages, official languages of the EU. And so this is what we needed, and then that's why we looked at it. And of course, it can be trained. A model can be trained to extract from French texts or German texts or any other text for that matter, but you would need to prepare the training data, and that's a long process. So for now, it only works for English.
And how do you, this is a question from Burku probably. How do you upload text to GPT? From which terms are to be extracted?
This is okay. We have, of course, using GPT at the commission. I mean, we have a dedicated model for us, which ensure that our data is protected, encrypted from end to end. And we have an interface which we use to upload files. But actually, as a matter of fact, even if you use the chat GPT, which is publicly available, you can now already upload files there. So you can use it. You can upload files, and that's it. I hope this answers the question.
Do we have anyone brave enough to ask a question live on camera? Some of you are asking about the presentation, so the recording will definitely be shared on this platform, on the TIFF platform, and you will be able to see the presentation and the video as well, of course. But whether the presentation will be available to download, this unfortunately is not something I can answer right now. I am checking, and I hope I get the reply in the next 5 minutes before we end the session. There is a question, Mateo. You see it. It goes back to the discussion we had before. How was TermiteOne trained for English?
Yes, I think for this one, I will just quickly show the one slide that shows this, if it's okay. And that's this slide. Hope you can see it. So here on the right, we have a sentence broken down. And so the training data is structured in such a way that each sentence is broken down into tokens. So they can be words or punctuation, spaces, things like that. And those tokens are then put into a single column. That's the first column of the table that the model uses to learn. The second column of the table is going to be the part of speech element of that token. And then the third column is going to be the indication of whether it's a term or not. And then, but I think, Borislav, if you want to compliment me, you are much more savvy in this than I am.
No, it's to explain it perfectly well. If there's some more questions for the audience, it will be nice. But this is I mean, we just take sentences in English, real sentences from EU legislation, of course. This is very important. And then we tag the real terms, the words, the combination of words we know that they are terms, and that's it. I mean, and then it's just a technicality how to tell to the model that it's a term. I mean, here we use BioS, but okay, we can use some other system. It depends on the library and everything.
Yes, but so the terms are always human defined. So we have terminology that we know is terminology because we use it in our work. That's, for example, data from YATE or data from definitions from legal acts, where you have usually Article 2 stating these are the defined terms that have their designated meaning. So that's terminology, which is human defined. And then once we have that terminology, we just extract sentences where that terminology is present. And we use that as training data. I hope that answers
And
it.
one last question is from Amelie, who in the end currently uses the terms that are extracted. Is it terminologists or translators from DGT, or is it still work in progress?
Well, the central terminology unit uses that in the early terminology work, but so they prune the lists and define what is actually worth turning into a terminology project for a particular translation, and then they cascade it down to the terminologists of the individual languages, who then complete the target side, and then these provide that to the translators, and they can use it for during their translation. I think this is the most frequent use currently, at least as far as I'm aware.
Just to jump in here for a small clarification, it's clear for us, but I would like to make it clear for everybody. Of course, everything extracted by a tool, even so nice tool as TermiteOne, should be seen by a human terminologist or translator to see if the extraction contains really terms, which combination of words are really terms, and to use them further for translation or to introduce them in YAT, etc. Human intervention is very important. But this is true also with the large language models. I mean, there is no way to replace people completely. You need experts, you need humans in the loop to look at the results and to validate them.
Thank you very much, Boris. Matej wanted to add something?
No.
No. We have 1 minute to go if there are any last questions. Otherwise, thank you very much, Matej and Borislav, for this presentation. There were more than 90 people in this session. I will stop the recording now.